The regulations and good airmanship require that during any phase of operation, the loading, mass and centre of gravity of the aircraft comply with the limitations specified in the approved aircraft flight manual, or the operations manual if it's more restrictive. It's the responsibility of the commander of the aircraft to satisfy himself that this requirement is met. More detailed explanations of mass and centre of gravity limitations are given in the lesson following this one. Limitations on mass are set to ensure adequate margins of strength and performance, and limitations on centre of gravity position are set to ensure adequate stability and control of the aircraft in flight. If the limiting mass of an aircraft is exceeded, performance is reduced, takeoff and landing distances will be increased, rate of climb and ceiling will be reduced, range and endurance will be reduced, maximum speed will be reduced, also stalling speed will be increased, manoeuvrability will be reduced, wear on tyres and brakes will be increased, and structural safety margins will be reduced. The maximum takeoff mass is defined as the maximum permissible total aircraft mass at the beginning of the takeoff run. The maximum landing mass is defined as the maximum permissible total aircraft mass upon landing, under normal circumstances. The maximum zero fuel mass is the maximum permissible mass of an aircraft with no usable fuel. If fuel must be retained in particular tanks for purposes of ballast or for centre of gravity reasons, it must be included in the zero fuel mass when it's specified in the airframe limitations. In service, an aircraft must observe certain speed limitations. These may be maximum speeds or minimum speeds, but in each case they are set to give safe operation in the prevailing conditions. The limits may be set by various considerations, the main ones being the strength of the aircraft structure, that is, the ability of the structure to withstand a load, the stiffness of the aircraft structure, which is the ability of the structure to withstand deformation, that adequate control of the aircraft be maintained at all times. The limit load is the maximum load to be expected in service. The ultimate load is the load at which the structure will fail. The safety factor is the ratio of the ultimate load to the limit load. For aircraft structures, the safety factor is 1.5. The safety factor on aircraft structures is much lower than the safety factors used in other forms of engineering because of the extreme importance of minimum weight in aircraft structures. To keep the weight as low as possible, the safety factor must be kept to a minimum. Because of this, it's extremely important not to exceed the limitations set on the operation of the aircraft, as the safety margin can easily be exceeded and structural damage occur. The airframe structure must obviously be strong enough to take the loads acting upon it in normal level flight, that is, the forces due to lift, drag, thrust, and weight. However, the aircraft is also required to manoeuvre and to fly in turbulent air. Under these conditions, the loads on the aircraft will be increased, so it must also be strong enough to perform whatever manoeuvres are specified for the aircraft, and to withstand the turbulence which the aircraft may reasonably be expected to encounter. The maximum load factors which must be allowed for during manoeuvres are shown in an envelope of speed, V, against load factor, N. Each aircraft type has its own particular VN diagram, with specific V's and N's. This diagram shows a typical maneuver envelope or VN diagram. The curve OA represents the increasing G-loading on the aircraft as the speed is increased with full backwards deflection of the control column. The maximum positive lift capability is initially limited because the aircraft will stall before the load limit factor is reached. At point A, the maximum positive lift capability will cause the loading on the structure to reach the positive limit load factor. The airspeed at this point is the minimum airspeed at which the positive limit load factor can be developed aerodynamically. The usual term to describe this speed is VA, or manoeuvring speed. If the aircraft is flown at speeds above that represented by point A, it must be borne in mind that any full or sudden deflection of the elevators will increase the load factor to a point where permanent deformation of the aircraft's primary structure may occur. If aircraft speed is increased still further, it will eventually reach the point where structural damage or failure will occur. This is the maximum speed which has to be considered when assessing the strength of the aircraft. The usual term used to describe this speed is the design dive speed, or VD. In general, VNE, the never exceed speed, which we will define later, is set at about 10% less than the design dive speed. Similar stresses will be developed in the aircraft structure during negative lift flight. However, the negative load factor limits are set lower than those for positive lift flight. We now superimpose upon the maneuver envelope the significant speeds and speed ranges with which, as a pilot, you will have to be very familiar. The speeds and speed ranges will be given in the aircraft manual as well as indicated by coloured arcs on the aircraft's airspeed indicator, or ASI. We'll look at the ASI indications a little later on in this lesson. Note that VNO, the higher limit of the normal operating range, is of a higher value than VA, the manoeuvring speed. VA is the maximum speed at which full or abrupt control deflections will result in a stall without the risk of causing structural damage. The aircraft can be operated quite safely above this speed as long as the manoeuvring envelope is fully understood. Above VA, the pilot should not use full, abrupt control deflections. The aircraft should not be flown in turbulent air at speeds above VNO. The speed range between VNO and VNE is the caution range and should be entered only in smooth air. As we've said, VNE is the speed never to exceed. Between VNE and VD, there is a danger of control surface flutter, which could lead to airframe structural damage or failure. The limit load factors will depend on the design category of the aircraft. The JAR regulations state that, for normal category aircraft, the positive limit load factor may not be less than 2.5 G and need not be more than 3.8 G. This is so that structural weight can be kept to an absolute minimum, so that a manufacturer will not design an aircraft to be stronger than the minimum required by the regulations. For utility aircraft, the positive limit load factor is 4.4 G. For aerobatic category aircraft, the positive limit load factor is 6 G. The negative limit load factor may not be less than minus 1 g for normal category aircraft, minus 1.76 g for utility category aircraft, minus 3 g for aerobatic category aircraft. On the airspeed indicator, a green arc indicates the normal operating speed range. VNO is the upper limit of the green arc. VNO is the normal operating cruise speed limit. VNE is the never exceed speed. Although the aircraft can be flown safely in still air conditions at this speed, it's good airmanship to allow a margin between VNE and the speed at which you are flying, just in case you encounter gusty conditions. Gusts encountered while flying at VNE may increase the loads on the aircraft structure to above the positive load limit factor. VNE is shown by a radial red line on the airspeed indicator at the high speed end of the yellow arc. From VNO to VNE, there will be a yellow arc, which is the caution range. You may fly at speeds within the yellow arc only in smooth air, and then only with caution. Some ASIs have two sets of coloured arcs to show the limiting speeds and speed ranges above and below a given operating mass. Flaps are designed to reduce takeoff and landing distances. The flaps and their operating mechanism and attachment points to the structure are not designed to withstand the loads which would be applied at high airspeeds. To indicate to the pilot the speeds at which he can fly without overstressing the aircraft, a white arc on the airspeed indicator dial extends from the aircraft's power-off landing configuration stalling speed to VFE. VFE, the flap's extended speed, is the maximum airspeed at which the aircraft should be flown with the flaps in a prescribed extended position. The landing gear will normally be retracted as soon as possible after takeoff, to reduce drag and increase the climb gradient. There is no normal requirement for the gear to be operated at high indicated airspeed, so the retract and extend mechanism, together with the attachment points to the structure, are sized for the required task. To design the gear for operation at high indicated airspeeds would unnecessarily increase structural weight. Thus, either 1 or 2 speed limitations will be specified for your aircraft, depending on system design. VLO is the landing gear operating speed. It's the speed at which it's safe both to extend and to retract the landing gear. If the extension speed is not the same as the retraction speed, the two speeds must be designated as VLO extend and VLO retract. When the gear is retracted or extended, the landing gear doors must open first. The doors merely streamline the undercarriage bay and are not designed to take the aerodynamic loads which would be placed on them at high indicated airspeeds. Consequently, VLO is usually lower than VLE. VLE is the landing gear extended speed. For flight in turbulence, an airspeed must be chosen to give protection against two possibilities: stalling and overstressing the aircraft structure. Because the rough airspeed has to satisfy these two requirements, it must be a compromise. If you find yourself flying in turbulent conditions, and there is no specified VRA for your aircraft, then fly at the design manoeuvre speed, VA, for the aircraft's instantaneous all-up weight. Remember that these speeds are targets. The turbulent conditions will cause your indicated airspeed to fluctuate, and by chasing a speed, you may overstress the aircraft. Remember also that the turbulence may cause your altitude to fluctuate wildly. Don't chase it. As long as you are in no danger of hitting the ground or other aircraft, allow the aircraft to ride the gusts.